Okay, so I'm going to try and record the videos in a little bit of a different way, so that maybe we can have them a little bit shorter and they won't be too much trouble to upload. Okay, so when we look at integration by parts, we're basically looking at this formula. So integration by parts is equal to u multiplied by v minus the integral of v du. This is the integration by parts formula. You need to remember it, but I'm going to show you some examples that will help explain exactly how we can apply it. Okay, so our first example will be this one. We have x to the power 2 sine 2x dx. Then we want to find the integral of this. Sorry. Now, when you look at this, we said firstly you have to ask yourself, does it fit the integration tables, the standard integrals? Then I don't think there's any standard integral that takes this form from the ones that we did the first time we did integration. So we can't do that. Can we use a u substitution? We can, but it's going to be a little bit cumbersome. What we ideally want is, once we substitute a u in here and find the derivative, we're supposed to get what's out here. So if this was 2x to the power 3, this would have been nice, because we would have gotten 6x to the power 2, which is x to the power 2, ignoring the constants. Anyways, so once it doesn't fit your integration tables, then once you realize you can't use u substitution, then you have to try integration by parts. Integration by parts basically means we divide this into parts. Now, there's one very important rule you need to follow, which is highlighted here. When you do an integration by parts, the integral must get better. That's what you want. Ideally, you want the integral to get better. Here's what I mean. Let's say in our first instance, we say u is equal to sine 2x, and then v, write this as v, is equal to the integral of x to the power 2. Now here's what happens. For the first part, the u, what's going to happen is du is going to be equal to here, so we just find the derivative of this, which will be 2 cos 2x, like that. Now look at the integral. The integral here will become v is equal to x to the power 3 over 3, like that. Now here the integral doesn't get better because the power is increasing. Ideally what you want is, once you integrate, at least your power becomes smaller. If we inserted this into our formula, this would be, it's equal to, u is this first part, so u is equal to sine 2x, like that. V is this part. Here we just said how you calculate v is by integrating x squared dx. So this is your value for v, which is x to the power 3 over 3, minus, then you do the integral of, then we have v, remember v is this one, over 3 multiplied by du. Du is this one, 2 cos 2x. Now notice what's happened. We have to integrate this whole thing. X power 3 multiplied by 2 cos 2x. Here again, if we're going to integrate this whole thing, it means we are going to have to use either the standard integrals, in which case they won't work. Use substitution. Here we have 2x. Then here we have, so that's 2x dx. I'll show you properly this. But anyways, again, we have to use integration by parts. And if we pick the same values that we picked in this case, where x to the power 3 is our v, then what's going to happen is this will keep going up. It will become x to the power 4, x to the power 5, x to the power 6, and we'll keep doing our solutions. So anyways, the point is you have to pick your v such that when you integrate it, the integration becomes better or easier to do. Let me show you what I mean. Look at this one. As opposed to picking your u as sine 2x, we're picking our u as x to the power 2. Then we're picking our v as the integral of sine 2x, like that. What this allows us to do is we can find, because remember our formula is u multiplied by v minus the integral of v du, like that. So what we want to do is, firstly we write u is equal to x to the power 2. Then differentiating x to the power 2 will give us du. Du in this case is equal to 2x dx. Or we can say, when we have u is equal to x power 2, then when we differentiate this will be du over dx is equal to 2x. But we want to make du the subject of the formula, so it will be du is equal to 2x dx. That's what we have here, 2x dx. Then our v, the value for v, which is this v over here, v is equal to the integral of our second function, which is sine 2x. Now the integral of v is equal to, we can use the standard integral, the standard tables here, the standard integrals, or we could use substitution to get this value, which is v is equal to negative cos 2x over 2. So I think that's okay. All right, let's now replace this into our formula. Now our formula is u v minus the integral of v du. Where we have u, we replace with x to the power 2. So that's this first part, x to the power 2. Where we have v, we replace with negative cos 2x over 2, which is this part, negative cos 2x over 2. Then minus the integral of v, the value for v is this one, negative cos 2x over 2, multiplied by du. Now look at du. Du is equal to 2x dx. So we replace this part with, which is the du, 2x dx. Then we can clean this up by getting rid of the 2's, so that we remain with negative x squared cos 2x over 2 plus, here we remain with, remember this x, so we have x cos 2x dx. Now I want you to compare this with this. Here's what we remained with last time. We remained with x power 3 over 3 multiplied by 2 cos 2x. Here we've remained with x cos 2x. Last time we had x to the power 3. Remember, we started out with x to the power 2. So this power has reduced, and that's ideally what we want. We want this power to reduce, so that when we look at this, we know we can do another integration by parts here. We could do a u substitution, but unfortunately our value here, 2x, if differentiated, if we took this as our u, the answer would just be dx, so we wouldn't get an answer that's also in the integral, which was like one of the conditions we had to satisfy. Okay, now we get this, then we do another integration by parts, which means we write our formula u v minus the integral of v du. U v minus the integral of v du. We get our u as x, u is equal to x, then we differentiate this, which will become du is equal to, because when we differentiate this, this will be 1 dx, so we can just write du is equal to dx. Then the next part, we say v is equal to cos 2x, which is this part. Now v is equal to cos 2x dx, when integrated, becomes v is equal to sine 2x over 2. Okay, that should be clear from our standard integrals. Then we can rewrite our formula. So we know u multiplied by v. Our u is this one, which is x. Our v is sine 2x over 2. So we're going to have these two multiply. X sine 2x divided by 2 minus the integral of v. Now the integral of v is this, so that's sine 2x over 2 multiplied by du. Du in this case is just dx, so dx like that. And ultimately what we're going to have here is, so we get our value here, which because we were solving for this one, this whole part was this. So now we can rewrite this, negative x squared cos 2x over 2 plus, which is the plus here, then we can write the integral of this whole thing, which is x sine 2x, this part, minus, then we find the integral for this. But remember, sine 2x, because we can take this over 2, we can take it outside, so we are basically just integrating sine 2x. But remember, we've already integrated sine 2x. We can easily integrate it here, but we also still have the value right here, which is the integral of sine 2x is negative cos 2x over 2. So what this means is we can easily take the 1 over 2 outside, which is this 2 outside, then we integrate the inside, which is sine 2x. We get negative cos 2x over 2, and because we don't have any limits on our integral, we're going to finish this off with plus c. Finally, what we get is negative x power 2 cos 2x over 2, the first part, plus the second part, x sine 2x over 2, plus, because we have a negative and another negative, when they multiply we get a positive, then the 2 and the 2 will also multiply, so we get 1 over 4 cos 2x plus c, and that will be our final answer here.